Lesson 1.3, this is transformations. We're going to start by finishing off your foldable. So if you will go back to your foldable from last class period, we're going to finish in the ones we didn't get to last class. So the reflection in the x-axis, we did talk about that on the last video. That's where you have a negative out in front. The other one we did not talk about was reflections in the y-axis. The only difference between the two of these is where the negative is. So with the x-axis, your negative is literally out in front. With the y-axis, your negative is going to be in front, but it's only with the x. So we call this inside with the x. I've already filled mine out, so you just go ahead and copy this down. On the inside, I want you to make yourself a note. Reflections on the y-axis, the negative is inside with the x. Here is an example, same thing, absolute value of negative x. Notice I have not given you a graph to go with it, and the reason is because the graph is a v. So if I have this graph and I flip it over the y-axis, in terms of a graph, you're not going to see anything change, especially with absolute value. Okay, so again, reflections in the x-axis and reflections in the y-axis both have to do with negatives. The difference is where is the negative. Ones on the outside in front are x-axis, ones inside with x are y-axis reflections. The other thing we talked about on the last video was your vertical stretches and your shrinks. And that's where we said, hey, you have a number that's literally out in front. Whether it's a stretch or a shrink depends on if that number is greater than 1 or less than 1. Numbers greater than 1 are stretches, less than 1 are shrinks. The one we did not talk about was horizontal stretches and shrinks. And again, these are very similar. Again, there is a number out in front for verticals. With horizontals, that number is inside with the x, much like the reflections that we just talked about. So again, your A is going to be inside with the x. Now remember, with horizontal translations, moving left and right, it was opposite. Left means adding, right means subtracting. It's opposite of what you would think. Same thing is kind of true with horizontal stretches and shrinks. So again, we're going to know that we have a stretch or a shrink based on the number. If there is a number inside the absolute value or inside parentheses, I know automatically that I'm looking at horizontals. Now, here's your example right here. So your A, that's your number. In this case, you would think that your A was 1/3, but horizontals are opposite. That's why we have this little note, horizontal, inside, opposite. So in all actuality, your A is the reciprocal when it comes to horizontals. That means you just flip the fraction. So our A here is 3. Once you know your A, the same rules apply. If it's greater than 1, it's a stretch. If it's less than 1, it's a shrink. So here, it's greater than 1. That means it's a horizontal stretch. And notice I've given you a graph. If we take this graph and stretch it horizontally, he's going to get wider. Go ahead and draw yourself a graph on yours. Filling in the information over here on the left, it stretches away from the y-axis. Remember, here's the y-axis, so I know that the graph is coming away from it. Your A is a number or a Dolly fraction. Remember, we talked about Dolly fractions on the last video, heavier on the top than they are on the bottom. Or it's just a regular number like this example is 3. And then obviously whenever we have horizontal stretches, your graph is going to get wider, as you saw with this example. So these are your horizontal translations. Horizontal, inside, opposite. Horizontal stretch, horizontal, inside, opposite. The inside is referring to where your number is, inside with the x, and it's opposite. That's referring to the reciprocal. Your other example, this is the example for the shrink. Here is the original formula, the absolute value of 3x. Again, I've got a number inside with the x. That tells me automatically that it's going to be a horizontal something, either stretch or shrink. In order to figure out if I have a stretch or a shrink, I got to know what my A is. And again, since I already know it's horizontal, my A is the reciprocal. Remember, this is just 3. Don't forget, that's the same thing as 3 over 1. So if I flip that fraction, I'm going to get 1/3. My A tells me if I have a stretch or a shrink. 1/3 is less than 1. This is a horizontal shrink. So I didn't draw you a graph, but here I will now. Here's my graph, and if we're going to stretch towards the y-axis, that means my graph's going to get more narrow. I guess I should have said shrink towards. We're going to squish it. So filling in your information over here on the left, it will shrink towards the y-axis. And your A is a fraction, which we already talked about. Less than 1, it's going to be a shrink. Your graph is going to get narrower or more narrow. I don't know. Whatever's correct English. All right, keep this handy. We're going to go work some problems using all of our transformations. All right. Writing equations for transformed functions. Example 1, we're going to let f of x, remember that's just notation, just a way to write, another way to write y, if you will. F of x equals 2x plus 1. I'm going to have you do a couple of things with this, but first, we're going to do translate. All right, let's do translated 3 units down. So if you need to, grab your foldable and take a look at it. Translated 3 units down, remember when we are moving up and down, that means we are adding or subtracting to the outside. So notice there's really no inside, there's no parentheses, or there's not any absolute value bars. So by default, this is already the outside. So I'm going to rewrite my equation. And I want to go 3 units down. Remember, when we're moving up and down, it's normal. So if we're going down, you would think we would subtract 3, and in fact that's true. So we'll subtract 3 from the outside. Now obviously these are like terms, so we need to combine this. Our final answer for our transformed function is 2x. 1 minus 3 is negative 2. Part B. So we're going to take the same equation, but we're going to do something different with it. This time, let's translate it to left. So as I just mentioned, there is no inside. We don't have parentheses or absolute value bars. And this part wants us to move left. So remember that when we're going left and right, we are either adding or subtracting on the inside. The inside specifically with x. Now when we're going left, don't forget, left is actually adding inside. But again, there's no inside, so we will have to make one. So here's my example. F of x equals 2x plus 1. And there's no inside, but we know that we want it to be inside with the x. So I'll make an inside using parentheses. In those parentheses, I'm going to put my x, and then my 2 units left. Well, I just add to the inside of the parentheses. So x plus 2. And then don't forget the remainder of your equation, plus 1. This would be that it's moving up 1, but we don't want to change that. We want it to stay the same. Now, don't forget your Algebra 1 rules. Anytime you have a number outside of parentheses, you can't just leave it that way. You got to distribute. 2 times x is 2x. 2 times 2, 4. And then I have that plus 1. Lastly, these are like terms. We can't just leave 4 plus 1 hanging out there. So my final answer, f of x equals 2x. 4 and 1 is 5. If you have any questions, stop the video and go back and listen to that part again. Example 2. We're going to use a different equation, so we're going to let f of x equal absolute value of x plus 3 plus 1. And again, we're going to do a couple of different things with this. So the first thing we're going to do is reflection in the x-axis. So if we go back to our foldable, you'll see that with reflections in the x-axis, we need a negative out in front. That's easy enough. So here's my equation. I'll literally need to put a negative out in front. So negative absolute value of x plus 3 plus 1. Now, a note to make here. Anything that you put out in front must be distributed. However, we talked about these absolute value bars looking like jail bars, and I'm going to refer to them as jail bars. You can't distribute in jail, not in real life. You can't just start distributing things in jail. So we can't distribute negatives or anything else into jail either. However, you can distribute to the guy standing in the back. So our final answer, negative absolute value, x plus 3, negative times 1, negative 1. Go ahead and write down that note. It's really, really important. Anything you put in front must be distributed. Another note you might want to make to yourself is you cannot distribute in jail. Okay. All right, example 3. Oh, wait, actually, we're going to use this equation again. So this will be B. We're going to do a reflection now in the y-axis. So same equation. Here's our original equation. We can go ahead and write this down again. F of x equals absolute value of x plus 3 plus 1. And this time we want a reflection in the y-axis. Going back to my foldable. Reflections in the y-axis mean a negative inside with x. Negative inside with x. Here's our equation, and we do have an inside this time. We've got absolute value bars, and the negative goes inside with the x. Keep in mind, this negative is not out in front, so this rule doesn't apply. It is not out in front. This rule does not apply. This negative does not get distributed. Another way you can think of that is the negative is already in jail. You can't distribute out of jail. Nothing goes in or out of jail. right, I'm going to give you a problem. I want you to try this one on your own. This is example 3. We're going to start with f of x equals absolute value of x minus 3 minus 5. And the first thing I want you to do with that is a horizontal shrink by 1/3. Now, one thing I want you to remember, horizontal, inside, opposite. Don't forget that. So take a minute, go back to your foldable if you need to, and figure out where that horizontal shrink needs to go. Come back and check your work. Okay, horizontals. Horizontal, inside, opposite. Opposite is the key thing here. First thing we need to do is identify what your A is. They said a horizontal shrink by 1/3. That means my A is actually 3. Now, as far as where am I supposed to put that 3, that's where your foldable comes in handy. Horizontal, they said horizontal shrink. Anything with horizontal, your A goes inside with the X. Inside with the X. So here, my A is 3. It's literally going to go inside with the X. Don't forget that the 3 is inside. It's already in jail. It does not distribute anywhere. Part B, try this one on your own. This is going to be a vertical stretch by 2. Pause the video and then come back and check your work. Okay, again, with stretches and shrinks, it's super important to figure out what your A actually is. We're talking about a vertical stretch. Verticals are normal. It's the horizontals that are opposite. So if it tells me a vertical stretch by 2, my A is 2. Going back to look at your foldable, it is a vertical stretch. We need to know where do I put this to? Vertical stretch, A, that's your number. It literally goes in front of jail or parentheses or whatever is already there. Okay, so it literally goes in front. Here's my original equation. So I have f of x equals, my A is 2, absolute value, x minus 3, minus 5. Now, do not forget, did you put that 2 there? Yes, you did. That means anything that you put in front must be distributed. I cannot distribute into jail. We can't do that. But we can distribute around jail to this guy standing back here. So we get f of x equals 2, absolute value of x minus 3. 2 times negative 5, negative 10. All right, example 4. We're going to do it a little bit, we're going to add more than one step. So each of these graphs can be transformed more than one time. We can move them up, then right, then we can reflect them. We can do anything pretty much with the graph. So up until now, we've been doing one thing at a time. So now we're going to take one equation, f of x equals absolute value of x, and do several different things with it. First thing we want is a translation up 2 units, followed by a vertical shrink, sorry. A vertical shrink by 1/2. And a reflection Make sure you're writing this problem down so you'll have it to refer to. A reflection in the x-axis. Okay, super important. Your word problems are going to look like this, and the order matters. So whatever order they give you, that's the order you have to do it in. So what I mean by that is the first thing they said was a translation up 2 units. That's the first thing we have to do. Followed by a vertical shrink. That's the second thing we have to do. And lastly, they want a reflection in the x-axis. It's best to number these things so that you know what order you're supposed to be doing them in. All right, so we're starting with f of x equals absolute value of x. And the first thing they wanted us to do was translate it up 2 units. Well, you guys know how to make things go up and down by now. Up and down are adding or subtracting on the outside. So basically what I need to do is, if I'm going up, I've got f of x equals absolute value of x. Up 2 units means add 2 to the outside. Good, I'm done with step 1. The second thing they wanted was a vertical shrink by 1/2. So number 2. Here's my now, I'm working with this equation now, and I need a vertical shrink by 1/2. Verticals are normal. Remember, we know with verticals and horizontals, we need to identify our A. They told us it was 1/2. Again, verticals are normal. The A is 1/2. And with verticals, those go literally out in front. So f of x equals my 1/2 is going to go out in front. Absolute value of x plus 2. Now the other thing you got to know about those 1/2 is you put it out in front. That means it must be distributed. We can't distribute in jail. We can distribute to the guy behind. So cleaning this up, I get 1/2 absolute value of x plus 1/2 times 2 is 1. Don't forget, anything you put in front must be distributed. And the last thing they wanted was a reflection in the x-axis. So this is step part 3. Reflections, those are negatives. But where does that negative go? So at this point, I've got f of x equals, negatives in the x-axis are literally out in front. Negative 1/2 absolute value of x plus 1. Again, you put that out in front. Anything that you put out in front, drop my pen, must be distributed. Cleaning this up, I have negative 1/2 absolute value of x. Negative times positive 1 is a negative 1. Final answer. All right, this is the end of 1.3. You can move on to your homework or classwork or whatever your teacher has planned for you. If you are confused at any part, please go back and re-listen to this.